The freedom of flight is only possible with careful attention to your aircraft. No matter where you're headed, get there safely with proper maintenance and regular inspections. Safety is paramount at Hartzell Aviation, where we build reliable products and power general aviation into the future. And we're growing, so let us introduce you to our family of companies. Hartzell Aviation's flagship is Hartzell Propeller, headquartered in Piqua, Ohio. Hartzell Propeller is the global leader in advanced aircraft propeller design and manufacturing technology for general aviation. Hartzell Service Center is where we provide aircraft propeller overhaul and repair. Hartzell Engine Tech is our leading OEM supplier and aerospace technology company. At Hartzell Aerospace Welding, you'll find an FAA Part 145 repair station and PMA holder for exhaust systems and engine mounts. Quality Aircraft Accessories, or QAA, is Hartzell's Part 145 Class 1 and Class 2 repair station with the in-house ability to overhaul most engine and airframe accessories. Today, we'll tap into expertise found across each of the Hartzell Aviation companies. Led by Hartzell Engine Tech's Director of Product and Technical Support, Alan Buffkin, we'll get maintenance and inspection guidance straight from the manufacturer.
Behind me is our Beechcraft Bonanza F-33 Alpha. This aircraft has been modified with a STC to put an IO 550. We're going to take this applicable checklist and concentrate on the Hartzell Aviation products firewall forward. So here we are with our F-33 Alpha Bonanza checklist. Using it as guidance, we've already ensured that the master switch is off. And in going through this checklist, we get to the part of the walk around for the propeller system. The checklist has on here check, but we want to go a little bit deeper than that. On this propeller, we want to do the same inspection that we would do for any 3-blade composite. So leading down the edge of the blade, we want to look for any nicks, gouges, or scratches for the leading edge. We also want to check the blade for radial play, in and out, fore and aft. As we make our way up the blade, we want to look for any excess oil or grease that we might see that would indicate a leak. We want to check the spinner for general security of the hardware all the way around. And we'll repeat that process for all 3 blades. This particular aircraft has electric de-ice. So as well, we want to look at the de-ice wiring, make sure the harness is connected, all wires secure, no chafing, nothing looks unwound. And also while we're here, we have a good view of the alternator. We want to check the alternator for general condition and security. We also want to check the attachment wires to the back of the alternator for the field, output, and any other accessory that might be connected. General condition, chafing, and security. And on this exhaust, all we're looking for is general security, condition, any corrosion present. We want to check clearance, and we also want to look for any fluid leakage that might be coming from the exhaust. But let's take a deeper look. Let's open up the cowling, get a better look at the accessories and the exhaust system. We'll take it from the standpoint of if we were going to do an oil change, possibly even 100-hour inspections. On this particular IO 550, in the case of us changing the oil or looking at it deeper for 100-hour, let's start with the electrical system. This particular alternator is equipped with the ALV 9610. This is a direct drive 100-amp style alternator. This view allows us a better opportunity to see the alternator back as a whole and inspect all the way forward. One of the first things that we would look at on the alternator is the condition of the wiring. We're looking for any chafing or burning that could be happening, any loose zip tie fasteners, as well as the condition of the rubber covers. We also want to check to make sure that the wires are tight, torqued properly. In this particular case, we also have an auxiliary which is used with the regulator system of this aircraft. It has a fuse in there. We want to make sure that the fuse holder is in good condition and the fuse is properly tied down. Grounds are connected and taut. We also want to look at the brush block assembly, make sure that our brush block hold screws are tightly into the case and nothing generally appears out of place or loose. We want to check the condition of the alternator as well where it's mounted to the engine, make sure everything is tight and torqued down. Direct drive alternators use a coupling assembly inside the engine. We recommend servicing this coupling per the manufacturer's recommendations. Typically it's a 500-hour or 2-year inspection for the coupling. We highly recommend that you adhere to that inspection. Now moving on from our alternator, we'll move back to the magneto and harness system. And for the inspection process of the magnetos, we always recommend following the particular manufacturer's service recommendations. For the purpose of a 100-hour, there would be certain checks involved on that 100-hour checklist, which would include the timing, etc. But let's say when our oil is draining, we want to do a good condition check. The main things we would look for is general security of the hardware and the magnetos to the engine. Nothing's loose, everything looks in good condition. There's no leaks or anything that's noted. We look at the overall condition of the magneto itself, checking its ground wires to ensure there's no chafing, no binding, nothing that looks unusual. Making our way to our harness assembly, we'll make sure that the harness assembly is fully seated, nothing looks loose out, and as well, there's no chafing or any major abnormalities in the harness as it sits. We'll check our zip tie connections. We'll also go all the way to the plug, checking the plug connections at that plug. We'll repeat that process for the harness on the lower side of the engine as well, and we'll also do that same process for the other side. Once we've completed that, we're satisfied that everything looks in good condition, we'll move on to the starter. And now as we move on to the starter, we get a good view of not just the starter adapter, but the starter itself. This is an Energizer style starter. The way that we would quickly inspect it, make sure there's no leaking. All our connection hardware to the engine looks good and secure. We also want to check our power input. We want to make sure that the terminal lead is tight, torqued down. There's no obvious signs of chafing, burning, anything on any of the associated wiring. We also want to follow that back, check it to the harness, make sure that where it connects into the harness looks good, no chafing or abnormalities. Now that we've got a more thorough look at the topside components, let's work our way down to the exhaust system. And for that, let's bring in our subject matter expert. I would like to introduce you to Mr. Tom Hyde of Hartzell Aerospace Welding. Tom, good to see you.
Alan, good to see you. It's a pleasure being here today.
Tom, can you tell me more about yourself?
Prior to joining Hartzell Aviation, I was one of the original owners of aerospace welding for 27 years. I've also been an A&P mechanic for the past 40 years, and I recently got my private pilot certificate.
Can you tell me more about this exhaust system from that simple inspection to the more complex 100-hour inspection?
Well, the two things that we really want to watch out from a safety standpoint whenever you're looking at the exhaust system, we're concerned about fire from the heat that the exhaust system creates. So we want to look for any kind of cracks or any joints that are not connected properly, loose hardware or anything like that. We're also concerned about carbon monoxide in the cockpit, since the cabin heater provides from the exhaust system the cabin heat for the cockpit. So during an oil change, you want to visually look over the whole exhaust system, and what you're looking for is any type of cracks or metal breakdown, heat distortion of any of the components. The metal might blister or be deformed in an area, or you might find a crack in one of the joints. You want to look at all the weld joints from the exhaust flange at the cylinder on down through the tailpipe. If there's an excess of exhaust leakage, be it through a clamp joint or slip joint or from a crack, you may see a white, yellow, or reddish type soot stain. Now, every joint's going to have a little bit of this leakage from the exhaust, but if there's an excessive amount of it, or it's in an area that is not where there's a clamp joint or at the weld joint, you want to inspect closer, because that could be a sign of a crack. And cracks can cause heat to come out of the exhaust where we don't want it. We've got a lot of wire bundles running in here, fuel lines, oil lines, and of course that could create a fire. The other thing we want to be concerned with, as I mentioned earlier, is carbon monoxide, because the exhaust system is where we get our heat for the cockpit. So we want to make sure that everything is sealed up tight and that we aren't getting any carbon monoxide into the cockpit. So we look over the exhaust stack here that comes down from the cylinders. Behind that, we have our muffler, cabin heater, and then we go down to the tailpipe. Now here is the tailpipe removed from the airplane. And as you can see, there's some severe damage here to the tailpipe. This was caught during a pre-flight inspection, where the pilot was simply walking around and saw this damage. Now, what causes this? This material is very thin. It's only 35 thousandths thick, and the erosion inside this material made the wall thickness thinner and thinner over time until it cracked open. Now, as we get into the 100-hour or an annual inspection, we'll go a little bit more deeper into the details of what we're looking for. The exhaust stack bolts onto the cylinders by the exhaust flanges. And there we have a gasket between the exhaust flange and the cylinder. If we see any kind of black excess soot in that area, we want to take a closer look at the exhaust gasket. Now, the reason we want those exhaust gaskets to not be leaking is we want to make sure if they leak over time in an excess way, they can erode the cylinder flange and the exhaust port on the cylinder, which would cause us to have to remove the cylinder from service. So we want to make sure those exhaust gaskets are not leaking. From there, we want to go down and look for anywhere we might have a slip joint. This particular exhaust stack has a slip joint in the middle cylinder. And the slip joints in the exhaust stacks are meant to have movement of those portions of the exhaust in a free manner due to heating and cooling cycles and the cylinders moving independently. These exhausts operate at about 1600 degrees F. So it's really important you have a high temp anti-seize and that you lubricate all slip joints throughout the exhaust system when you have those components apart and have an opportunity to apply the anti-seize. We also want to go down further and look at any of the ball joints or clamp joints where the different components connect to each other. We want to make sure there's not excess exhaust leakage in that area. We want to make sure all the hardware is intact. We want to make sure everything is connected correctly and not loose and rattling around. From there, we go back to the muffler. On this particular case, on this side of the aircraft is also our cabin heater. Well, that's where we really get concerned about carbon monoxide. You want to remove the muffler from the exhaust system, and you want to remove the cabin heat shroud, which would be around the muffler. You want to take a good look at the body of the muffler, make sure, again, there's no heat distortion, no holes, no cracks, because all of this will allow the exhaust gas to escape into the cabin heat chamber. And when you select cabin heat, that carbon monoxide would go into the cockpit, which of course we want to prevent that from happening. But it's always a good practice to pressure check your muffler. Now, the way we do this is we cap off one end of the muffler and we feed low pressure air into the muffler. Through a vacuum cleaner, you can reverse the flow and simply use that, or you can use shop air. You only need about 3 to 5 PSI to pressurize the muffler. Taking some soap and water solution, spray it on the muffler, and if there's any leaks or cracks in the heat chamber, you will see bubbles. And if you see any bubbles at all, take it out of service and replace with a new muffler. The other thing you want to look for in the muffler when you have it apart, most mufflers have a baffle within them to deaden the noise, quiet it down, but also to help disperse the heat more evenly throughout the muffler. Now, the baffle inside the muffler can, over time, become distorted through heat. It also can get damaged during a backfire. If you ever have a backfire on a carbureted engine, you really want to take that airplane out of service, remove the muffler, and take a good look at the baffling inside the muffler, because a backfire is an explosion inside the muffler, which can severely damage the baffling as well as the body of the muffler, possibly create a crack. Now, as you can see in this muffler, the baffle has come apart and has lodged itself in the outlet of the muffler where the tailpipe would be connected. Now, this would cause a power loss within the aircraft because it is plugging the outlet of the exhaust. This would be very critical on takeoff when you need full power, so this is a very critical thing to keep an eye on. Here's another example of the baffle in a cutaway version of the muffler, and you can see how the baffle has distorted over time from heat, and again, is not flowing the exhaust correctly out of the tailpipe area.
Tom, I want to thank you for your time and expertise today. I hope to see you again soon.
Thank you, Alan. It was a pleasure being here.
And here to tell us more about our 3-blade composite propeller is our subject matter expert, Jareth Woody. Jareth, good to see you today. Tell us a little bit more about yourself.
I've got 12 years of aviation experience, where I've worked as a mechanic in GA, commercial, and military experience. I'm a certified A&P mechanic and a licensed private pilot.
Can you tell me more about our propeller we have here today?
So during our pre-flight inspection, we took a look at the camber, face, lead edge, trail edge, and tip of our propeller blades. During maintenance inspection, we may require that the blade be repaired or dressed properly. Unlike an aluminum blade, a composite blade has a couple additional factors to it. We have a nickel erosion shield, and the material itself is made up of composite. If we see an inflation in the composite material or suspect cracking or debonding, a coin tap may be necessary to be performed. Also, unlike an aluminum blade, on a composite blade, we should never try to dress the nickel erosion shield. This may lead to cracks and additional damage, which would make this propeller unairworthy. On the appearance of the blade, we could actually find ourselves with missing paint. Sandblasting, which is just simply erosion on the blade, is an airworthy condition. However, any more than an excess of 5 square inches or approximately 13 square centimeters should be addressed during our routine maintenance and our scheduled maintenance. So additionally, during our pre-flight inspection, we tried to note or find any lightning strike damage. This would have shown up as any brown, residue, or soot appearance on the actual paint itself. This typically happens at the tip and leads inboard on our composite blade. During routine maintenance inspection, we should take off the spinner and look at our internal system to see if any arcing has occurred on any other part. This compact 3-bladed composite propeller is equipped with an ice protection system, which is de-ice. This is an electrical system which has elements in a rubber boot installed on the propeller blade. Depending on the boot type that's installed on the propeller assembly, the maximum allowable is typically or generally 3 square inches or approximately 8 square centimeters of debonded material before repair. As we note on our blades, we're going to look out for on our GVI whether or not we have any streaking or smearing or even splatter along the camber or face of the blade. This is essentially would indicate an O-ring that has failed at the hub. So additionally, to determine the difference between oil and grease that's may be indicated on the blade, a UV light can be used. This would pick up an oil additive that has photoluminescent property under that UV light.
Now, Jared, can you tell me more about what I'm looking for radial and axial play of the blade for inspection?
So the radial play is essentially a term that we call preload. Preload occurs at shutdown and startup of the propeller assembly. We'd like to keep the blades taut inside the hub assembly. So for that, we have in and out play, fore and aft, and in play at the tip of the propeller blade. This should return when pressed upon in its original position.
Now, Jared, since we have the spinner removed, the hub exposed, is there anything aft of this assembly, inspection-wise or critical, that we need to be looking at since we have all of this exposed?
So with this system, we have a de-ice ice protection system installed. This has several leads, as you can see, running from the blade boot to the bulkhead, and then going aft to the slip ring assembly. The slip ring assembly also comes into contact with a brush block, which is installed on the engine, and the bracket is installed on the engine block. These components will require a general visual inspection at 200 hours, but may also coincide with the scheduled maintenance at the 100-hour inspection. So with the spinner dome removed, we have access that we couldn't normally see on a pre-flight inspection with just a flashlight and a mirror. Here we can tell if our hardware is loose or missing, as well as any of the pieces that may need additional torque. The cylinder is placarded with the type of grease that's used in the propeller assembly. As you can tell here, we have Nyco GN3058. This grease was actually put into production for all assembled propellers from Hartzell Propeller starting the year 2020. This should not be mixed with Aeroshell 5 or 6. These two types of greases should not be mixed together, as the reaction may have adverse effects and cause internal wear within the system. The hours of the coin tap on a composite propeller blade are not to exceed 1,200 hours on any of the exposed surfaces of the blade, and not to exceed more than 600 flight hours on the nickel erosion shield.
Now, Jared, I understand that if I know my propeller model, I can go direct to the website and find any applicable service bulletins or ADs for my particular propeller model?
That is correct. So the propeller model, which can be referenced not only in your owner's manual or logbook that came with the propeller assembly, but actually pin stamped on your assembly on the cylinder side hub half. That model designation can be used, and the blade type, if known or seen from the butt of the blade, can actually be used to input in the system. When you know that, it will populate a list of ADs, service bulletins, service letters, and service instructions that may be applicable to this propeller assembly.
Well, Jared, that's a lot of good information to know. I want to thank you for coming today.
Absolutely.
I hope you enjoyed our video today on our Beechcraft Bonanza as part of our Hartzell Aviation series. I would also like to thank our subject matter experts who participated in the video today. At Hartzell Aviation, we are dedicated to providing aviation products and services that deliver uncompromising quality, performance, and support. For more information or to contact us directly, please contact us at hartzellaviation.com.